Let's now look at another one of those problems with averages. All right, the second one there. The manager of a fast food restaurant wants to know the average number of customers per hour arriving at the restaurant during lunchtime. A random sample of 30 lunchtime hours yielded an average of 175 customers per hour, with a standard deviation of 32 customers per hour. Last month, from a similar sample of 35 lunchtime hours, yielded an average of 150, with a standard deviation of 28 customers per hour. Calculate the 95% confidence interval for the increase in the average number of arriving customers per hour during lunchtime. All right, this time it asks us for the increase. Remember last time it asked us for the difference, and the difference we really don't care which way it is. We could have swapped those samples around. We would have, instead of having an interval on the negative side, got an interval on the positive side, but it would have been just as valid as the interval that we calculated. But in this case, we're asked to find the increase. All right, so we have 175 in the earlier sample. Okay, sorry, 175 in the new sample, and 150 from the old. All right, so the increase is 25 customers. So we'll try to get our samples in an order to make that work. All right, some students like to put the sample first, which has the largest average or later proportion. Makes things a little easier to handle, but it's not necessary always. But quite often it doesn't hurt. Alright, so to arrange a positive difference here, we'll do this month is 1 and last month is 2. Alright, this month 30 customers, last month 35. We'll need our averages. All right, the average from this month 175, this month 150. All right, difference there is 25. That's the increase. And standard deviations 32 and 28 respectively. All right, so oops. 32 and 28. And again, we're looking for a 95% confidence interval for the true difference. If you've got a feel for what's going on, just stop the video here and work it out yourself. Alright, but I'm going to continue here. So x bar 1 minus x bar 2 plus or minus the appropriate z-value. That gives us 95% of the normal distribution between those two z-values times s of x bar. From our previous problem, we saw that the z-value that does that is the 1.96, so 95% of the normal distribution is between plus and minus 1.96 standard deviations. X bar 1 minus x bar 2, 175 minus 150, it's a 25 customers per hour increase, and we need the standard deviation s sub x bar 1 minus x bar 2, s1 squared on n1 plus s2 squared on n2, 32 squared divided by 30 plus 28 squared divided by 35. Don't forget the square root sign. Let's go to Excel and work that out. Alright, square root of 32 squared divided by 30 plus 28 squared divided by 35. Alright, 7.519. Four significant places. And so our confidence interval is equal to the sample difference, the sample increase, plus or minus appropriate z-value 1.96 times standard deviation 7.519. So it's 25 minus 1.96 times the standard deviation, and 25 plus 1.96 times the standard deviation. So our interval goes from 10.26 to 39.74. So 10.26 to 39.74. Alright, so we're saying that we're 95% confident that the true increase in the number of customers from last month to this month is somewhere between 10-ish to about 40 customers. Of course, it's a wide interval. If you want a better estimate, you'd have to take larger samples. All right, but at the moment, that's the end of this problem. Okay. And I'm going to stop this video here and then continue with the next video with two sample proportions with confidence intervals.